Okay, we talked today about percent change. Problem number 2 says the prices are rolling back on Halloween candy. The bag of candy corn that used to be $4 is now $1.50. What is the percent of change? So we talked about this formula. The reason I like this formula is because often when I encounter a percent change problem, I know it's just the difference between the two prices divided by one of the prices, but I can never remember whether I'm supposed to divide by the original price or the new price. The percent is changing. I mean, the percent change is based on the change from the original price, so it makes sense that we would divide by the original value. But I always have to sort of check myself when I'm doing a problem like this if I haven't done one for a while. So if you're going to use this, by the way, this percent change formula, it's not useful for every single problem on the homework. If you're already given the percent change, I think it's easier to just use a ratio table. And I'm actually going to show you both ways on this problem. The percent change will be equal to the new value, which in this case is $1.50, minus the original value, which is $4, divided by the original value, $4. We'll just say 4. Well, okay, I'll show and then multiplied by 100. So we'll evaluate that later, but you may notice that if you do $1.50 minus $4, you're going to get a negative result. And the reason for that is by doing it that way, we'll end up getting a negative percent change, which indicates that it's a decrease in the percent. I mean, it's a price decrease, so it's a percent change in the negative direction. I'd like to also show you how these can be done very easily with a percent table. So we're comparing dollars to percent. The $4 price is 100% of that's the original price, so that's the 100% amount. The $1.50 is the new price, so we just want to know what percent is that. Now X won't be the answer to the question. X won't be the percent change. But once we know X, we can calculate the percent change by finding a difference between the original percent, 100%, and the new percent. So you can try solving it using either one of those methods, and then come back after the pause and we can compare which one seems more efficient.
Paused.
Okay, if I continue with this formula, we get percent change is equal to negative 2.5 over 4 multiplied by 100. And I mean, it'd be kind of easy just to multiply the 2.5 by 100, so negative 250, because then all I have to do is move this decimal 2 places to the right. So our percent change is going to be 250 divided by 4. It'll be negative, of course, because negative divided by positive is negative. So if I do 250 divided by 4 over here, I get 6 fours is 24. Subtract, I get 1, bring down the 0. There are 2 4s in 10. 2 times 4 is 8. Subtract, I get a difference of 2. Reveal the 0 in the tens place. It was always there. We're just showing it, and line up a decimal in our quotient. And then bring this 0 down. How many 4s in 20? 5. 5 times 4 is 20. So it's a negative 62.5% change. If we use the table method, you could certainly write a proportion from here, but there's a very easy scale factor that jumps out at you if you're looking for it. 4 multiplied by 25 is 100. So we can do 1.5 multiplied by 25. Remember, you can do scale factors horizontally or vertically in your table. You just can't do them diagonally. If we're doing them horizontally like this, it's like multiplying this fraction by 1 whole. And if we're doing it vertically, it's like multiplying this fraction by 1 whole, which you're allowed to do that in either case. Doing it diagonally would be multiplying, for example, multiplying one side of your equation by 4 and dividing the other side by 4, so that's not allowed. Since we identified this scale factor of 25, I can just do 25 multiplied by 1.5. 5 times 5 is 25. Carry the 2. 2 5s is 10 and 1 is 2. I'll start with a 0 because now I'm multiplying by 10. 5 multiplied by 1 is 5. 2 multiplied by 1 is 2. So I get 375 here, but I have to remember I was multiplying wholes by tenths, so that should give me tenths. So x is 37.5. You might think, well, why is that not matching our other answer using the other method? Because this is not the percent change. This is the percent represented by the $1.50 price. The $1.50 price is 37.5% of the original price. The percent change is how much did the percent change? It went from 100 to 375. So 100 minus, not 375, 37.5. 100 minus 37.5. There's your 62.5% change. And you could say 62.5% decrease, or you could say negative 62.5%. In either case, you're indicating that the price went down by that percentage. Okay, I hope that helped with the homework.